All right. Hey, how's it going, guys? So now you got your day 5 of our new unit, right? Fifth asynchronous lesson, feasible region practice, the name of this assignment. Now, I think I'm counting this one as a mini quiz. So I am going to look at the quality of your answers. So I do hope you're watching this video because I'm going to tell you, walk you through the whole thing. If you just want to just do it along with me and as an accompaniment, do it. Because I want to make sure you get this, right? It's hard to come up with these inequalities, these math sentences at the beginning. That's why we did it as a class. And if you didn't copy them down correctly, if you still didn't really get them, you're pretty much screwed with the rest of this quiz. So that's the reason why I'm going to do it again, so that you can write them down correctly. You can correct mistakes here. So, and then afterwards, right, you might not remember, right? You're like, I've only taught you a couple times about how to graph a linear inequality and what are some quick ways you can do it. And maybe you haven't had enough practice yet. That's why you're watching this video, because some people can get it, right? Some people figured it out. Other people might need to see this as an example. So what I don't want to see when I look at the task later is I don't want to see people who still aren't getting it after the third time or still can't watch this video to get it here. That's why this video is going to exist, is because I want to give you that third chance, right? Third chance to try to figure out how to graph these things, okay? What's still very hard is coming up with the inequalities themselves. What can help you is to define variables. Remember, variables in a problem are going to be the things that are the unknowns, okay? What do we know? Well, we know that there's got to be 18 people. So the number of people isn't, or it says at least 18 people, but people isn't going to be a variable. $7.50 maximum for postage. That $750.50 is fixed. It's a fixed number. So fixed numbers aren't variables. Variables are things that could change within the context of the problem here. Destiny's budgeted $7.50 maximum for postage. So postcards cost 30 cents. Well, let X equal 30 cents. Now, it doesn't make sense because 30 cents is how much it costs. That's not going to change in the problem. The thing that changes in the problem is the amount of postcards in this scenario. She's trying to figure out how many postcards she could potentially make, how many letters she can potentially make. So those are the two changing things in this problem. She wants to figure out how many she can make. There's no question. Like usually there's a question at the end. How many postcards can she send? How many letters can she send? So that's usually what you use to define. So we're going to let X equal the number of postcards Destiny sends. We're letting our readers know this, and we're letting you know it too, right? Destiny sends. And then let Y equal the number of letters Destiny ends up sending. Okay, go ahead and submit that. Move on to the next slide here. Okay, so we came up with these inequalities in class here, and we were like doing it for like 20 minutes. So they are tricky here, but let's try to break it down here. Okay, so first thing here is I might do the total amount constraint. So there are going to be two constraints in this problem. One is going to be a cost constraint. How can she manage to keep her budget? How can she spend less than $7.50? Is it okay if she spends $7.50? Yes, it is. So she can spend up to $7.50. That's why we see maximum right here. That suggests this is going to be an inequality. You see the word maximum here, okay? So there's going to be a money constraint. There's also a total number of postcards and letters she's going to send out, right? She's going to send those to at least 18 people. They're at least going to get one postcard each or one letter each. So my first inequality is going to be the total quantity inequality. So the number of postcards plus the number of letters, which she's deciding how much to write, she knows that she needs to send it greater than or equal to 18. 18 right there. Okay, she needs to send at least, it's okay if she sends 19 letters postcards. It's okay if she sends 20, right? She doesn't want to send at least that much, but she's further constrained by a cost constraint. Okay, so here's my total number constraint, and we're constrained because we need to send at least 18. We're also constrained by the fact that the amount it's going to cost, and I'm going to do 30 cents here for every postcard, right? When we see things that each postcard, we can infer the word each or per or every postcard costs 30 cents. Each postcard costs 30 cents. Postcards are 30 cents per postcard. When we see that, that just simply means it's going to kind of look like a slope, 30 cents per postcard. Take the number of postcards, multiply it by 30 cents. That's the total amount of cents. 30x is the total amount of cents that would be spent on all the postcards she makes, depending upon X, depending on how she chooses. So 30x plus, well, a letter costs 50 cents to mail, or 50y, and we're constrained by the fact is that we got to keep that underneath 750 cents. And there you have it. Let's look at it here. Okay, so those are your two inequalities that I recommend you roll with. You could have also have written it in terms of dollars. So $7.5, right, $7.50, and then 50 cents per letter, or $0.50 per letter, and then or 3/10 of a dollar for each postcard. That could have been a way to set this one up, but I'm not going to do that. I'm going to set it up here, and this is legit. This is just 100 times on the left side and the right side, which we're allowed to do. So, anyways, 30 cents per postcard plus 50 cents per letter is less than or equal to the 750 cents we have to send those things here. Submit and explain. I already explained it. You should explain there too. All right, you don't have to do this because you're not with your groups today. Now we need to figure it out. Let's graph these things out. Let's do this. Okay, let's label our axes. What was X again? Let's do that first. Okay, do it along with me. I'll just do the whole thing. Like, this is what I'll be looking for when I check your little quiz here, mini quiz. Okay, X is the number. Maybe I'm just gonna label it up here. So there's not a lot of space there down at the bottom, so I'll get rid of this. This here, X variable is the, oh wait, you can do the labels down here. That's nice. Okay, X axis label is going to be the number of, the question mark still there. I don't want the question mark there anymore. Number of postcards. That's any sense. See, it's getting out of the way. I'll just do number of postcards. Okay, number of postcards. Y variable is going to be the number of letters. Okay, our unit in this equation is just the number of, right? We count the number of letters she makes. It's not like 6 inches of letters, 8 inches of letters. So it's not measured in inches, it's measured in just the number of them that exist, okay? Number of letters, those are my X and Y axes. So now I gotta figure out how I can graph this, okay? And it says use your screen to show your work. So I might go to the next screen because I'm gonna maybe start by graphing this one out first. X plus Y is greater than or equal to 18. So I'm gonna move over this and oh, look at that, we have 4 people working on this right now. Very nice, okay? And I might graph this one out here. So I'm gonna show my work and how I'm going to graph. Remember, there are 2 steps to graphing out an inequality, okay? Step 1, okay, so let's graph this one, okay? Our goal here is on a graph X plus Y is greater than or equal to 18. Okay, so step 1, I'm going to figure out how to graph X plus Y equals 18. Remember, we want to graph a line first, and that's going to be the boundary line, right? Boundary line is a vocabulary word, you know. It's going to separate our true solutions from our false solutions. Okay, so I need to graph the line X plus Y equals 18. And the way I would do that is, it says, be sure you can show how you get at least 2 points on each line, okay? 2 points on each line. The way I'm going to do that is I'm going to get my x-intercept. I'm going to get my x-intercept. My x-intercept is the value of x in this equation when y equals 0. Okay, when y equals 0. Okay, so when y is 0, x has got to equal what? Well, it's got to equal 18. Okay, if she sends 0 letters to people, then she's got to send at least 18 postcards to people. Okay, so I have a y-intercept. Sorry, an x-intercept at 18, which is right here. And I'm going to also get my y-intercept, and that's also going to be 18, right? I don't even really need to show work here. My y-intercept is simply the value of y when x equals 0. So I'm going to put 0 here, and I'm going to do plus y equal to 18. And I might as well show your work out, and I get y equals 18. Okay, so my y-intercept is this. Value of y when x equals 0. Okay? Does that show on my other graph? Let's see if that actually shows up here. Move over here. It doesn't show, okay? But I'm going to have to graph that, okay? So maybe what I'm going to do, it says I chose correct scale for both axes. I need to, because my y-intercept, I need to get it to at least 18. So here we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to maybe scale by, I'll count up 5 to show it. 1, 2, 3, 4, 5. There's 5. 1, 2, 3, 4, 5. There's 5. 1, 2, 3, 4, 5. 15, 16, 17, 18. Okay, this is 18 right here. Okay, and there's my x-intercept, number of postcards. You can send 18 postcards, at least 18 postcards if she's sending no letters. Same thing's going to be true here, letters. So I'm just going to scale by ones here, basically. But I'm just going to show every 5 here. 1, 2, 3, 4, 5. And then I'm going to go up 1, 2, 3, 4, 5. Oops, a little bit too high. 4, 5. And then here we go. 1, 2, 3, 4, 5. Okay, there's 15, so I'm going to go 1, 2, 3 more, and this is 18 right here. Okay, there's my y-intercept here at 18. Okay, I'm going to draw my borderline in here. So check it out. Borderline. Boom. There we go. My borderline here. Okay, so I'm going to do that, and I got to figure out what my inequality is going to be like. So let's check this one out here, and use the screen to show your work on the previous screen. So I'm going to graph that. And wow, we actually don't have that much like notepad to show here. So step 1 was to graph the boundary line. I did that already. Step 2 is to, okay, I'm going to test 0, 0. I'm going to test a point, right? Test a point to figure out if 0, 0 is part of the solution region. Okay, so I'm going to test that. Test 0, 0 in the original inequality, right? In the original inequality. So 0 plus 0, is that greater than or equal to 18? 0 plus 0, is that greater than or equal to 18? Well, is 0 greater than? 0 bigger than 18? No, that's false, okay? So that's false. Okay, so what we need to do is, right, we need to, okay, 0, 0 is not in solution region for this inequality, so we need to shade the other direction, okay? So what you're gonna do back here, I'm not gonna shade towards 0, 0, right? Here's 0, 0 right here. That's the origin, okay? This is point 0, 0. It's not a solution, right? We need to send at least 18 postcards. So here, over here is, this is, maybe I'll do blue, right? So we have the same color in this one here. Blue constraint will be the total quantity constraint. So all these are okay for sending at least, to mailing at least the amount of people she wants to mail to, okay? So I'll go ahead and shade it in, right? It's impossible to shade the whole thing because pencils are only so good as covering part of the plane, not the whole plane here, the whole surface. But that's the idea, is that these are where my solution regions are. 0, 0 is not a solution, okay? Now I gotta get the other one, right? This one's a little bit harder, so maybe I'll clear this out so that you can do this one here. So I gotta do this next one here. Maybe I'll do the next one in green. Okay, now I gotta graph my other inequality, which is gonna be 30x plus 50y is less than or equal to 750. Okay, step 1, equation. X plus 50y equals 750. How do I graph my boundary point, right? Gotta graph my boundary point here. So I'm gonna plug in 0 for one of these. Let's plug in 0 for x and get my y-intercept. So this is 0, and this is going to close parentheses, and I'm going to have 50y here. That equals 750. So the nice thing about getting a y-intercept is that the x, this quantity goes away. 30 times 0 is just 0. So I'm left with 50y equal to 750. Well, I just divide both sides by 50 to figure out where my y-intercept is. Okay, and y is going to equal, and you can do this in your head if you knew your head. If not, always have your calculator out. I can do 750 and divide it by 50, and that's going to be 15. Okay, so I'm going to have a y-intercept here at 15. Okay, so I'm going to do when x is 0, it returns a y-intercept of 15. So she can send at most 15 letters if she didn't send any postcards based on the money constraints. Okay, remember, this is the total quantity constraint up here, then we got the money constraint just below. Okay, so there's my first point. I need to get a second point. Oops, I don't need the 2 there. The 2 was going to be for me testing a point here. So now I got to get my x-intercept. So 30x plus 50 times by, this is where I'm going to put in 0, okay, because I'm going to put in 0 for y and figure out where my x-intercept is. That's why they call this the intercepts method of graphing a standard form equation. This is 750. This goes away. Okay, what do I do to both sides? I divide both sides by 30, right? That's it. And that's going to tell me my x-intercept, which is going to be 750 divided by 30. And those numbers are kind of related here, huh? 25. Okay, we get 25. I don't know what that meant. What did I just say? Related? I don't get it. Anyways, we both ended 5. So 25 there. Okay, so there we go. We have it. And now I'm starting to get a little worried because do I have enough space to have an x-intercept at 25? Oh no. Oh no. What have I done? I might have to regraph this thing. Hopefully you don't find yourself in this situation. Anyways, let's go ahead and graph the boundary line. Let's do that here. Are we going to be able to get to 25? I think so. If that's 18, this is 19, that's 20, that's 21, 22, 23, 24, 25. There's 25, and there's where my x-intercept is. And I was saying I was going to do the other constraints in green. So ideally, you're doing two different colors, right? And if we're doing this in class, we get the colored pencils out, right? We get that out. We're shading, and we're finding overlapping regions, the feasible region, okay? So 25, 0 is 1. And now I need to test. Well, actually, no, my y-intercept's 15, right? We got 0, 15 is where the y-intercept is. So that's up here, right? Remember, this is 15. So now I'm going to connect 25, 0 and 0, 15 with one another. And there you have it. Boom. There you go. Okay, there we go. So now the question is, do I shade below this green line or do I shade above this green line? So what I need to do is I need to test a point. Okay, test a point. Step 2, remember step 2, graphing inequality is test a point. So I'm going to test 0, 0 again. Okay, 30. Test the origin, see if the origin's a solution. 30 times by 0. I'll do that in red so you can see it a little more clearly. 30 times by 0. And this plus 50 times by, you guessed it, 0. Is that going to be less than or equal to 750? Because that was my inequality, 750. 750. I can't barely read it, but that says 750 right there. Well, this just becomes 0. That just becomes 0. Is 0 less than or equal to 750? And yes, that's true. Okay, so that's true. True. So that means that 0, 0, okay, 0, 0 is in solution region. Is in solution region. Oh, can't even read it there. True, 0, 0 is in solution region. Yeah, you falling asleep? You falling asleep? I don't know. Let's see here. 0, 0 is in solution region. Let's shade. Let's freaking shade it right now. Okay, so what we can shade here, 0, 0 is actually true, right? This is true in the situation. I got my green line there. I can highlight everything down below this. This all works within the total money constraint. It makes sense. You can generally never have to spend a certain amount of money. You usually have to keep your spending down below a particular constraint. And look at this here. Okay, look at this here. I think we'll be able to find this feasible region very quickly. But yeah, there's a lot going on. Ooh, messy, okay? I graphed them both here, okay? So I labeled my axes. Yes, I did. Number of postcards, number of letters. I chose the correct scale. Yeah, I just had to scale by ones here. I should have showed precise points, 2 points per line, and show work to find these 2 points. Yes, I did. I maybe didn't label this 15 right here, so I'm going to label this 15. And there's 25. Good to go. So these are all things I'll be checking, right? Checking when I check your guys' work here. I showed precise points, 2 per line. There we go. Show my work to find those points. Yes, I did. I did that over here. At least enough work for one of the 2 lines for me to verify that you got it. I graphed both lines, and I shaded the inequality. And I showed I know how. Yes, I did show that because I tested a point down here. Okay, so I'll be looking for that. That's why that check mark was in there. Okay, so that was half the battle of the past couple weeks, was just how do you graph an inequality. Now it's time to interpret it. Okay, so we'll go to slide 9 right now. And now they want you to do this on Desmos because they want you to double check you got it correctly. Graph both equalities in this graph to check your work. Okay, make them 2 different colors. So now we're taking this super messy thing, which maybe you can see the feasible region in there. Maybe you can see it right here, but it's easier to see if you have a tool that will do this for you, right? Do this for you. So let's do this here. X plus y is greater than or equal to 18. And here we have 30x plus 50y is less than or equal to 750. And there we go. What the heck? Nope, 75-750. And there we go. Yep, that's what I graphed. I think I did it right. Hey, pat myself in the back. Where's the feasible region? Where's the feasible region? What does it mean? Okay, what does it mean? We'll talk about that in a second. All right, going to the next slide, slide 10. There we go. There's my graph. Cool. It's showing it to me. That's pretty neat. It says outline your feasible region in the sketch. Okay, feasible region means what's possible. What satisfies all the constraints. Okay, so if I know I have my points up here, remember, up here, this region up here, okay, this region up here works for red, not for blue. Okay, this region down here Blue is good. Red? Not so much. Okay, not so much. So my feasible region, this is what you need to do on this one. Need to outline it here where it overlaps one another. Yeah, your feasible region in the sketch. Okay, so my recommendation is, because remember, we have some unspoken constraints, right? Unspoken constraints. And that is our domain is just positive numbers, right? Our domain is just positive numbers. So I'm actually going to change the graphs real quick in a second. Let's maybe check this one out here. I might change my domain. You don't have to do this, but I'll be impressed if you follow this direction. So, okay. I can send at least 0, right? At least 0 letters. I can't send less than 0, so I'm gonna put that here. And I'm gonna adjust my domain here. I can have to send at least, that was postcards above this. Wait, sorry, at least 0 postcard in both situations. Let's do that here. So if I restrict my domain, this is a better viewpoint of this here. But I guess I want to make my ranges positive too, right? Y has to be greater than or equal to 0. So this is a really neat way. Yeah, there we go. So this all has to be in quadrant 1, right? Quadrant 1 is up here. Remember, it goes 1, 2, 3, 4, and quadrant 1 is where all your positive values are. We have some unspoken constraints in this one that all our x and y values need to be greater than 0, because we can't send like negative amounts of postcards. That makes no sense. So here, this is a better graph here, which I figured I'd show it that way. So that's pretty neat if you got that here. Oh, it disappeared. Oh, wait, there it is. There it is. It's good to go. All right, so to show my feasible region, what are the combinations he can send? It's going to be that there, down here, and that there. Okay, and so here, it's not very big, just highlight it. There's my feasible region. Maybe you point to it too. Okay, maybe I'll do this here. Boom. There's my feasible region. It's so hard to draw on this. Okay? Explain what this region means for the situation. All combinations of postcards and letters that Destiny can send to satisfy her constraints, right? Constraints, right? It means that, which means any combination will have her in the feasible region, right? Any combination in the feasible will result in mailing at least 18 letters and postcards and spending no more than $7.50. Okay, so I included that second part because that's a little bit more. It says in the context of the situation. So what it means for our situation, I want to talk about the situation. That region of points spends less than $7.50, and it mails out at least 18 of the two of them combined. Okay, number 11. Man, people work on this. This is kind of a hard one here, so maybe it would be easier if you waited for the video. According to this graph, where do you think Destiny maximizes her constraints? That is, how many postcards and letters allow her to spend exactly $7.50? Is she able to send all 18 of her friends and family? So where is the $7.50? We're going to think maybe the $7.50 thing here. The $7.50 thing here is going to be on the borderline, okay, on the borderline. So here, right, this whole borderline means exactly, because remember this was an equation that we had earlier, okay? This borderline here is showing us, okay, exactly $7.50 spent. And anything down here lower than this in the blue is less than $7.50. So it's okay. It's still part of the solution region for it. This is where the feasible region is, because this is more 18 here. So according to the graph, where did Destiny maximize her constraints? That is how many postcards and letters. So exactly $7.50. Somewhere on this point is going to answer this question, this final question right here. And the question is, can she send to all 18 of her friends and family, and why? So all 18 would be where, well, this is 18. Yeah, she sure can right here. Look, right here. So maybe this is where the point is here, because this point here the boundary here, this is exactly 18. She wants to send, so ideally, like I think it's probably better she sends to more than 18 people, right? She can spend all the way up here. But here, this is part of the feasible region, which shows, because it's the beginning of this constraint, which is at least 18, that part, that borderline is exactly 18 people got a postcard or a letter, okay? So is she able to send to all 18 of her friends and family? Yes, she can send, and maybe we should figure out, zoom in here, get our graphs a little bit hard to see. Okay, it looks like she can send, a little more than 4. So maybe find a combination that works. Okay, this is, now we're scaling by 4s here. Man, this is messy. Maybe you have to get it on a different graph here. Okay, so she can send maybe like 15. Looks like 15 postcards and 5. Right, 5 letters. She can send 15 postcards and 5 letters, and she's good to go. Okay, 15 postcards and 3 letters and 4 letters is fine too. That would satisfy the constraints. But there's an example, okay? And that's in the feasible region. And, she could send all the way up to, these kids are already options here, right? She can send all the way up to 25, it looks like, right? And still be okay. She sent 25 postcards, then sent it to 25 friends. She still spent less than $7.50, which is kind of nice, or exactly $7.50. So that might be her best option, right? Her best option might be right here. So they actually call this is something, if you study this in economics, I was actually an economics major in college, but this is something called a linear constraints problem, right? Constraints problem. But if you look to the corners of the feasible region, right? I definitely took freshman year classes in college where it's like always look at the corners of the feasible region, because that's going to give you the best option here. And for me, looking at, if you wanted to maximize the amount of things she could send to people, this corner is the best, 25. Right? She could send 25 postcards, and that would get it to 25 people. And this is in both the red graph and the blue graph right here. Right? So she can send as many as 25 postcards. 0 letters if she wants to maximize the amount of people that get some mail from her. Whew! And that is it. Man, that was tough. There's no way we were going to get through all that in 35 minutes. Even if I just got you to work. So that's why I spent the 25 minutes trying to just get the inequalities, get you thinking about this one, because this is really a finish for homework. So it's kind of a take-home mini quiz over the weekend. Sorry, but hopefully you watch it. Anyways, let me know what you think about it today. I enjoy problems like that. They can be kind of confusing, but I dig it. Have a great weekend. I will talk to you later. Email me if you have any questions. I know that my explanations can be confusing sometimes. So hopefully this allows you to finish the assignment, but also hopefully understand it as well as you want to understand. Have a good one. Bye.